Okay, this is question 1. At the beginning of the sheet is when I'm going to remind everybody which things you need to memorize and which things will be provided for you. You do need to already know the combined gas law equation and what everything stands for. That will not be given to you. If you don't know your combined gas law equation tomorrow, you will have a problem. All right, this will be provided for you on your reference table. This may or may not come into play, but you should have memorized it already for heat equations. So if you do not know how to convert between Celsius and Kelvin, make sure you know how to do it when you come in for your quiz tomorrow. Okay, so first things first, we're going to do number 1. I'm going to walk you through it just like we did in class, except right now it's just me and you, and there is no one else here who can distract us. Okay, so first thing I had everybody do was carefully read through the question and list all the variables. This is a critical step, and basically as soon as everybody walked away from me and had to solve problems that didn't have the variables set up for them, you all stopped setting up your variables. You must do this. Okay, eventually you won't have to do it anymore, but most of you do need to do a systematic problem solving. And the reason why is because you are short-circuiting your ability to do very good problem solving when you don't write out all your steps and all your variables. You're getting stuck because you're losing track of your work because you don't actually have enough practice doing it this way for you to make sure that you can do a systematic problem solving strategy. So make sure that you're in the beginning listing all your variables and substituting into the equation appropriately. So first thing I come across is that the sample is at 298 Kelvin. That's my first temperature. Then it says that the volume is 145 milliliters. Then it says that my pressure is 125 kPa. Then it says that my pressure is pressure 2. All right. So the gas is then compressed to a volume of 80 milliliters. When you see that a change has happened, you have now moved on to the second state. Okay, so don't forget, these are initial, that's starting, and final state problems. So you have a first state, right, where you had a sample of gas and it was just doing its thing. And then you have a second state, which is when you did something to the gas that changed some of these variables like pressure, temperature, or volume. So right away, they're telling you that they're compressing, they're squishing the gas, and they're saying now it's only 80 milliliters, the container. Okay, there's a new pressure. I don't know what the new pressure is. I squished it, so definitely the pressure probably went up because my volume went down. And I know that that's true because this is a relationship in Boyle's law. Now, it tells me also that the temperature is held. This is a key word I told everybody to watch out for, that my temperature is not going to change. So when my temperature doesn't change, that tells me I'm going to knock it out. Okay, at this point, if you are a person who has not attempted these by yourself and you're not sure you know how to do it, I want you to pause this video, do the problem without me, then watch me do it. Okay, you're not going to get anything out of this if you just watch me do it. You will not be able to do it by yourself unless you actually try it by yourself, right? So I'm going to do a set of steps here. The first thing I'm going to do is I'm always going to write out my formula. P1 V1 over T1 equals P2 V2 over T2. Okay, second step, I recognize that something is held constant. So temperature gets held constant in this equation, which knocks it out of the equation, giving me only Boyle's law. So to save time, I'm only going to plug into Boyle's law. Okay, then I'm going to go ahead and substitute into this equation. Here's my variables already nice and lined up for me, so I know where to put my numbers. Okay, now for the purposes of focusing on algebra, no, you know what? I will leave the units in this time because I had a lot of people who got really weirded out by the fact that we were multiplying units, different units. You can multiply different units. times, it says times, P times, whenever you see formulas where you have two variables right next to each other, you're multiplying them. This is times 145 milliliters equals 80 milliliters is my second volume times P2. I don't know what P2 is. I'm solving for it. Okay. Now I'm going to go ahead and try and get P2 by itself. So I am allowed. So this is actually a little confusing, but it's not untrue. So I had some people got stuck here and were like, I can't multiply these two things because they're different units, right? So think of this in algebra as if I had 2a times 2b versus 2a plus 2b, right? Here, you're absolutely right. I'm not allowed to combine these two terms. However, when you're multiplying, you are actually allowed to do this. You would actually just get 4ab. You're allowed to multiply variables. You're not allowed to combine them by addition or subtraction. Yeah, we're not going to get into why that's true. I'm not a math teacher. I'm not going to explain the background algebra to you. But so a lot of you got stuck because you were actually in a very correct way. You were thinking about these as algebraic variables, these units, and they do behave that way in the equation when you're manipulating them. So it's okay for you to do that. Just keep in mind that you are allowed to multiply and divide them. Okay. So now what I'm going to do, sorry guys, I have some messages popping up on my screen and I have to get rid of them. Go ahead. All right. Now what I'm going to do is I'm going to go ahead and multiply these. So I get 125 times 145 is 18,125. And that's actually kPa dot milliliters because they're still being multiplied by each other. Okay, so that's basically your chemistry equivalent of saying A times B. Now I can continue with my equation. And when I continue, I've got 80 milliliters. Now, this is the point where I start to see people drop their variable. You can't drop your variable. Okay, either make this an X or keep it P2. Okay, it can be whatever letter you want. And make sure you are remembering that this is multiplying. Okay, so what you need to do to get P2 by itself is get 80 milliliters to go over there. So since this is multiplication in algebra, my rules say I have to do the opposite operation of what it's doing now. So I'm going to go ahead and divide both sides by 80 milliliters. And this is where your units will cancel. Okay, here it cancels completely. And I'm going to end up with P2 equals. And here milliliters cancels and I will get left with kPa. I'm doing the math quickly in the background. Sorry, you guys. Okay, and it came out to be 226. The other thing I keep hearing over and over again, you guys are so adorable. You're like, there's so many decimals, I don't know what to do. You just round to a number, okay? So I usually say unless we're using a question where it specifically says to do it to significant figures, which we're going to get the hang of that in lab because significant figures is really for laboratory data. Um, right now, let's just go to 22656. Okay, so 226.56 kPa. Okay, if you wanted to round smaller than that, you could. If you wanted to go higher than that, you could. I generally speaking would go to the hundreds place or the tens place. I would accept it if you, at this point in the game, you rounded that up to 7. Generally speaking, though, in chemistry, we wouldn't really do that because depending on the types of measurements you're taking, you could lose data by, you right now you have a half of a kilopascal. by going up to 227, you gave yourself a whole kilopascal, which you might not have actually, that's a lot. Like it's a big increase. That would be like saying, if I gave you 1.5 cookies and I was like, well, I gave you 2 cookies. And you were like, no, you gave me 1.5 cookies. Um, I think you would be unhappy if I rounded that up to 2 and tried to pretend I gave you 2 cookies, right? So if you think about like how you're losing actual, you're not your measure how inaccurate that measurement would be if I rounded up to 227, it would be pretty inaccurate. It would be as inaccurate as me saying that I gave you 2 cookies when I actually only gave you 1.5 cookies. And truthfully, when it comes to cookies, that's a really big discrepancy, in my opinion. All right, that's the end of the first video.